Alright, in this video I'm going to show you adding and subtracting rational numbers. Now this will be the first of two videos, so you'll have to look out for the second one if you would like to see that. So the important thing is we're adding and subtracting fractions. So whenever you're thinking about these problems, you could always think back to the most basic types of problems you faced maybe when you were younger. So like if I had 1/2 plus 2/3, anytime we wanted to add or subtract these fractions, we need the common denominator. So 2 and 3, you could probably remember, oh, I could probably make these to be 6. So you can multiply this times 2, that times 2, this times 3, that times 3. And you would change that into 3/6 plus 4 over 6. And notice how that, since they have common denominators, you could add and subtract to say, well, 3 plus 4 is 7 over 6. So if you think back to the basic problems, that'll help you kind of remember how to do these. So you need common denominators, so we look for least common multiples in the denominators. Only add the tops and then have it divided by 6. So on this problem, we're going to find the sum or difference. So I have 3x squared divided by x minus 8 plus 6x divided by x minus 8. So notice how we have common denominators already. I have an x minus 8 over here, I have an x minus 8 over there. Because of that, that means we can add these fractions together. So when we're adding, remember that denominators are going to stay the same. So I have an x minus 8, those are common, so I'm still going to have an x minus 8 in the denominator. What's going to change is the top. So we have 3x squared plus 6x, which is 3x squared plus 6x. I can't add those together because one of these has an x squared, one of them has just a plain old x. So I've now taken two fractions, added them together, and I have a single fraction. Now the only thing left to do is we would like to simplify this fraction if possible. So remember, with simplifying, we're going to factor the top and bottom and look to cross out common factors that are both on top and bottom. So on top I have 3x squared plus 6x, so I want to look and see, well, can I pull anything out of both of these? And I can. There's a GCF of 3x there, which means I have an x plus 2 left over. So a 3x and an x plus 2 is how I'm going to factor the top. On bottom I have x minus 8. I look to factor that, so I have x minus 8. Nothing else I can do to factor there. So what I'm looking for is I'm looking for common factors both on top and bottom. You'll see there's not really any common factors there, so we are done. So some of these problems, they're going to happen really quick, and that's fine. Other problems, we might have some simplifying we can do. So my next example, I'm now going to show you what happens if we don't have a common denominator. So I have a 5x in this denominator, 6x in that denominator. So the first thing I want to look forward to is trying to figure out what is my common denominator. Now there's different kind of methods and approaches for this. I think the easiest is factor each of your denominators, which right now they both are, and then list out all your factors. So I have 5x there, so I need a 5, I need an x. Great. Move to this one. It says I need a 6, so I don't have a 6 in this list yet, so I'm going to add a 6, and then I need another x. Notice how x shows up again. I'm not going to list another x since I already accounted for it in my list. So I have 5 times x times 6. Well, that is the same as 30x. So my denominators need to be 30x before I can add and subtract these together. So looking at our setup here, 12 divided by 5x minus 7 divided by 6x, I need to first start working on this 5x. So I got to figure out 5x times what will give me 30x. So that is going to be 5 times 6 gives me 30. I already have the x. So I'm going to multiply the bottom by 6. And if I'm multiplying the bottom by 6, I have to multiply the top by 6 as well. So when I do that, 6 times 12, I'm going to have 72 over 30x. Now I want to focus on my other fraction there. So I have a 6x in the denominator. I need a 30x there. 6x, I need a 30x. So I got to think 6x times what gets me 30x? Well, I'm missing that 5 there. So I multiply the bottom by 5. I'm going to multiply the top by 5. So I still have this subtraction sign. 7 times 5 is going to give me 35. And on bottom, 6x times 5 is 30x. Now when I subtract those, since now I have my common denominators, 72 minus 35, that is going to be 37. And since I have common denominators, I was allowed to do that, and I'm going to keep my 30x. The last step there is I want to look and see, hey, is there anything I can do to simplify this? 37 over 30, not a whole lot we can do there. So again, it becomes a case of, hey, we just subtract these with common denominators, and you're done. So one last example of the type of style problem you might see. We have 3 divided by x plus 4 minus 1 divided by x plus 6. So again, I see that I don't have common denominators, but I would like to get there. So first thing I'm going to do is I would factor. Well, x plus 4 is already factored, so I'm going to start making my list here. One of my factors is x plus 4. Then I move over here. I would like to factor x plus 6. It already is. So I'm going to add that to my list, x plus 6. So by common denominator, the denominator I need an x plus 4, and I need an x plus 6 in my denominators there. So going back to this problem, I have 3 divided by x plus 4 minus 1 divided by x plus 6. So I got an x plus 4, need an x plus 6. So I have an x plus 4, I need an x plus 6. So I'm going to multiply an x plus 6 there. So now you can kind of visually see it. I need x plus 4, x plus 6. There's my x plus 4, just included my x plus 6. Now the deal is if I multiply by x plus 6 on the bottom, I also have to do it on the top. The only catch is I'm only going to multiply the top. I'm going to leave the bottom alone. So I want to make sure my denominator still keeps looking like the common denominator I said I would have. So I'm still going to leave x plus 6 and x plus 4 down there. I'm not going to multiply those. The top, the numerator, I am going to multiply. I'm going to take this 3 and multiply it through. So 3 times x is 3x. 3 times 6 is 18. So 3 times x plus 6 is 3x plus 18. Still subtracting there. So now let's deal with this right fraction. So I have an x plus 6 in the denominator. I need an x plus 4. So x plus 4 on bottom and on top. Again, I'm going to leave the denominator alone because I want it to look like the common denominator I said I would have. But up top, I'm going to multiply. So I'm going to take 1 times x plus 4, which is just going to give me x plus 4. So now looking at this, I just transformed and changed, we'll call it, my fractions, but nothing really changed a whole lot there. So I have common denominators, which allows me to add and subtract here. So be very careful with the subtraction problem. So I'm going to take 3x minus x. 3x minus x, which is going to be 2x. And I'm going to have 18 minus 4. 18 minus 4 is 14. So I'm going to have 2x plus 14 in my numerator. In the denominator, I still have x plus 6 and x plus 4. The only thing left to do is I would like to simplify my final fraction there. The bottom C is already factored. That's why I definitely did not multiply on the bottoms, because I would have given myself extra work. So we are already factored on the bottom. So I just need to factor up in the numerator. So 2x plus 14. There is a GCF there. I could pull a 2 out. So I have 2 times x plus 7. And I have x plus 6 and x plus 4. So what I'm looking for is I'm looking for common factors on the numerator denominator. There are none there. So that is going to be my final answer. Just 2 times x plus 7 divided by x plus 6 times x plus 4. That was adding and subtracting rational numbers 1. This is pretty basic problems. And adding and subtracting rationals 2, we'll look at more difficult problems.